Boom. Anybody still need to sign in? Anybody come late?
No.
All right. The new stuff. Here we go. Where do I want to start? Start with instructions. Well, real quick, where are we? We just finished spring break. What a great spring break it was. This week is all about exponential. Today, we're going to get really into Excel, solving exponential probabilities with Excel. Thursday, we're going to learn how to do it manually. The hardest part of today's lecture that you need to focus on is Lambda. Write this definition down, put stars around it, circle it, write yourself little notes next to it, whatever words you need to use to try to refresh your mind as to how to calculate Lambda. This is the hardest part of this week, right there, Lambda. The next week we're getting into that, like I said, independent events will be your hardest part of next week. And then quiz 3, the following week after that. But in the first part of week 10, we're learning, again, I can't remember, ignore what it says there. I think we're learning something new. And then we do quiz 3 on Thursday. So, let's look at this one.
When is quiz 3?
Quiz 3 is on Thursday, what was the date?
21st.
The 21st, 2.5 weeks from today. Wow. Is it? Is it today your birthday? Put it on the board. That's not your birthday today?
What's your birthday? No way. Happy birthday.
Almost.
He's the 21st?
Yeah, how old am I? This will be good.
I think you told us that.
Did I already tell you? Shoot. All right. How old am I today? I'll give you a hint. I could start Social Security today.
65.
No, yeah, that's Medicare. Oh, okay, I can't start Social Security. Yeah, I can start. No, that's Medicare. I can get
Oh,
Medicare.
62.
There you go. But I'm here. I could be getting Social Security. Yeah, I'm still standing here. What the heck's going on? What the heck's going on? What am I doing here?
Small.
Oh, there you go. Okay, where are we? Week 8. We have 2 assignments. You have your written assignment, your Excel assignment. Let me show you something about the written assignment. The written assignment has 1, 2, 3 problems. We're going to go over Thursday in detail how to solve these problems. There's the written portion. Again, the hardest part is Lambda on these. Then the Excel, let me show you these. You have, number 1 has 3 different Excel equations you got to do, and number 2 has 3 also, I believe. Let me keep going. Yeah, 3. Right there in these yellow boxes are your 3 equations. Again, we're doing this just like we've been doing it all the semester except for that 1 week. You're writing these out by hand on paper, hand them in next Tuesday, a week from today, just like in previous weeks with your written assignment. So, but you're using Excel to get what the results are for each of these equations. So you have 6 Excel equations and 3 written equations this week. Not bad. Let's get into it. When is it due? It's due Tuesday, March 12th, a week from today. PowerPoint. Chapter 6 is your most important PowerPoint, really. Chapter 6 PowerPoint, 35 to 40. Textbook, 136 to 128, 221 to 223. Add to that 228. Add to that page 228. These are the examples we're going to talk about, and this will be a good way to refresh your memory when you're looking at an exponential problem, is because these examples cover all kinds of different ways they could be read to you, or that you could be reading them. The hardest part about exponential is Lambda and recognizing it. Recognizing it. So here's the deal. You have learned Poisson questions already, and with Poisson, you're being told the mean or average, and you're also being asked a question about how many. But with Poisson, the question about the probability of something is always about how many per interval. With exponential, it's the opposite. Now, let me make this clear. In a question that's exponential, you'll start reading it, you'll go, oh, this is Poisson, because it reads just like it. Until you get to that sentence that says, what's the probability of? This is how you recognize whether it's really Poisson or exponential. What's the probability of? That sentence that starts with, find the probability of, or what's the probability of? That's the sentence you then determine, hey, is this exponential or Poisson? If it's exponential, it will be asking you the probability of the interval between the events. Let me repeat that. If it's exponential, it will say, what's the probability of an interval between events? Hey, what's the probability there'll be 3 minutes between the next two cars that pull up to this gas pump? That's exponential. Did you hear it? I asked about the 3 minutes between the next two cars coming up to the gas pump. What's the probability there'll be 3 minutes between the two events of cars pulling up to the gas pump? That's exponential. Let me ask it now as Poisson. You ready? What's the probability there'll be 3 cars pulling up to the gas pump in the next 15 minutes?
Just one again.
I asked you about the event of cars pulling up to the gas pump over an interval. That's Poisson. Did everybody hear that? Let me repeat it. This is Poisson again. What's the probability there'll be 3 cars pulling up to the gas pump in the next 15 minutes? I asked you about the event of cars pulling up over an interval of 15 minutes. That's Poisson. Let me go back to exponential. What's the probability there'll be 3 minutes between the next 2 cars pulling up to the gas pump? I asked you about the interval between the events of the cars pulling up the gas pump. That's exponential.
So the keyword is between.
Say it again.
The keyword is between.
Yeah, the key word is not in between because it's worded so many different ways. That's why I'm going to go over so many examples today. I want you to see the different ways worded. Now here's the real word. Here's the real world weird part. Exponential sometimes will describe the mean exactly like Poisson does, and sometimes exponential will describe the mean differently than Poisson does, describing it as an interval instead of how many. And so you can never use the mean description to determine what kind of problem you have in front of you because it could be either one. You gotta wait till you read the probability part. But the probability part's described so many different ways, you can't rely on words like in between. Matter of fact, sometimes it says, what's the probability there's 3 minutes before the next car pulls up? I didn't say anything about in between, but you have to make the assumption we're talking about cars about to pull away, the next one's about to pull up. And yet it is in between 2 cars, but I never said the word between. And a lot of these don't say the word between, in between. Go ahead, Fatima, what was your question? Do you remember?
Oh, I just wanted you to repeat the Poisson.
Okay, the Poisson, and here you go. We'll say, what's the probability of a certain amount of something during an interval? Like 5, what's the probability there'll be 3 cars pulling up to the gas pump in the next 15 minutes? I asked about how many of something during an interval. That's Poisson. Now let me take that same thing and go exponential again. What's the probability there'll be 3 minutes before the next car pulls up to the gas pump? Almost as if a car just left. Do you get it? Go ahead. Go ahead.
So basically, they're just flipped.
It is kind of flipped.
It's,
one's asking about how many, one's asking about how much time or how much length or something like that. One is how many, one is how much.
The one that has time is the Poisson.
The one that has minutes
The
first
ones
is-
that, they both have time involved. The one that's asking how much time or how much distance, that's exponential. The one that's asking how many during the time or how many during the distance, that's Poisson. I'm telling you, this is the hardest part, you guys. If there's anything you need to focus on quiz 3 in the final exam, is recognizing the difference between Poisson and exponential, because the amount of points you will lose using the wrong formula is not worth the risk. That's one question. Thinking it was exponential when really it was Poisson will almost ruin your grade. And so you gotta be able to see the difference between the two. I saw someone with their hand up, I forgot who had their hand up just a minute ago. No one?
I think it was me. You said exponential is how much time, and Poisson is how many?
Yes, Poisson is how many, and exponential is how much. It could be time, it could be distance though, don't just put the word time there. How much interval. The interval is described different ways. Sometimes it's time, sometimes it's length, sometimes it's this, that, but it's an interval. That's why I'm gonna read a bunch of examples. I hope we don't run out of time. I wanna read a bunch of examples so that you can, tell the difference. So, here we go. I'm gonna turn these 3 examples, these 3 words here into exponential questions. The mean's being described, any way it's being described, blah, 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 blah. There it is. What's the probability that there'll be 3 minutes between cars arriving at this toll booth? Notice I asked about the 3 minutes between the cars arriving at the toll booth. That question about the probability of 3 minutes is how you go, oh, this is exponential. The next one, let's see. What's the probability that the next person taking that questionnaire will take 10 minutes to finish it? No, that's exponential because it asked about the 10 minutes. What's the probability it'll take 10 minutes to finish that questionnaire or survey? Here we go. What's the probability there'll be a mile between the next two defects on the highway?
Poisson.
No, that's exponential because I asked about the probability of a mile between the two. A mile, the probability of the mile between two. Now, if I said, hey, what's the probability there's two potholes in the next mile of highway? Now it's Poisson. Get it? Now it's Poisson. But I asked about the probability of the mile between the two. Between them. Yeah, but I don't, it's not always between. Don't rely on the word between. Don't rely on that word. It says between here, and it says between here, but look at the second one, doesn't say between. I'm trying not to confuse you, but I think it'll be more confusing if you're relying on the word between, because there's so many of them that don't use the word between. You're gonna go, but the word between wasn't there. That's because a lot of them don't use the word between. You can't rely on that. You ready? As exponential or as Poisson? Okay, exponential. We're talking about the second one. It says time required to complete a questionnaire. I'm going to start with exponential. What's the probability that the next questionnaire will take, the next person doing the questionnaire will take 20 minutes to fill it out or more? That's exponential. Because I was asking you the probability of how much time it would take for them to do the event of filling out the questionnaire. Now let me turn it into Poisson. What's the probability we'll have 3 questionnaires handed in the next 20 minutes? I was asking you about how many questionnaires during an interval of 20 minutes. That's Poisson. Because I was asking the probability of 3 questionnaires being handed in. That's Poisson. I know, it's hard, you guys. So let's go straight to an example. Here we go. Now the mean's being described differently than you've seen before, but don't think that makes it exponential. It just happens to be the way the mean's being described this time, that's all. It's when you get to the part where it says, what's the probability of, that you're now gonna go, oh, this is exponential. So it says, hey, the time between A1's full service gas pump, blah, 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 forget that, because I won't put that in the question. It has a mean time between arrivals of 3 minutes. Let me say that again. This gas station has a mean time of 3 minutes between cars pulling up to the pump. You with me? That's being described just like exponential problem almost, but that's just the mean. Poisson sometimes will even describe the mean this way, so don't rely on the mean being described to determine what kind of problem you have. Let me keep going. A1 would like to know the probability, there it is. When you see the words, what's the probability of, now this is the sentence you go, okay, is this Poisson or is this exponential? What's the probability of, where it's asking you that part. They want to know what the probability that the time between 2 successful arrivals at the gas pump is 2 minutes or less. It's asking you the probability about 2 minutes or less between cars coming to the gas pump. That's how you know it's exponential. Because if this were Poisson, it would say, what's the probability there'll be 2 cars in the next 10 minutes? It's asking you then how many cars in an interval. This is asking you about 2 minutes between the next 2 cars. That's how you know it's exponential. Go.
Can you describe it without the word between?
Okay, without the word between. Yes, you ready? A1 would like to know the probability that the probability that there'll be 2 minutes or less before the next car arrives. Almost as if one car just left, right? From right now to the next car arrives, 2 minutes or less. I'm still asking the probability about 2 minutes or less. That's how you know it's exponential, even though I didn't say anything about between 2 cars. Even though I didn't say anything about between 2 cars. All right. Now here's the deal. Are you ready? What you're being asked about, 2 minutes or less, that's the first number when you use Excel. Equals exponential distribution, number being asked the probability of. Just like that first number. Don't change it. Even if it's a more than, equals 1 minus exponential distribution. The number being asked about, you don't change it, just like normal distribution. Don't get me wrong, Poisson and binomial, yes, on a more than, we would use the opposite as the first number. But this uses continuous data, so we never change that first number, even on a more than question for exponential. We never change that first number. So it's asking for 2 minutes or more. So 2 minutes or more, am I using the top equation or the bottom equation? Bottom, 1 minus, so this first number is a 2. The last number is a 1. Look at that, we almost got it solved. Now here it comes, here it is. Everyone wake up. Hang on, wake up, I know. Oh, because it said or more. It said, what's the probability of 2 minutes? Oh, it says 2 minutes or less. Why did we use the bottom one? Sorry, I thought it said 2 minutes or more. Hang on, my bad. You guys, 2 minutes or less, 2 minutes or less. Hang on, I gotta correct this. Thank you. 2 minutes or less. God, this word said more. 2 minutes or less, so we're using the top one. Lambda. Here's the deal. You gotta say, what interval is the probability question asking about? Minutes. 2 minutes or less. What is the interval the probability question is asking about? Minutes. So now you gotta say, okay, what would be the mean number of events, which are cars pulling up to the gas pump, during 1 unit of the interval being asked about in the question? So we have to make this lambda, how many cars, let me write this down for you, how many cars per 1. This is the key here. Always 1. Lambda always represents just 1 unit of the interval that's being asked about in the question. So how many cars per 1 minute? The reason we're using 1 minute is because the question is about 2 minutes.
So it will change? It's not gonna be always 1 minute?
The lambda will always be 1 unit of whatever the question is asking about, because the question is asking about minutes, that's why it's 1 minute. But if this said, hey, what's the probability of there being, let's say this says 2 hours or less between cars pulling up to the pump, then our lambda would be how many cars go to that pump on average per 1 hour. Whatever that interval the question is, our lambda is how many per 1 unit of that interval. If this were in seconds, what's the probability there'll be 2 seconds or less between the next 2 cars? Then lambda is how many per 1 second. You get it? Okay, now that we know what lambda is, we gotta go back and read how the mean is being described and convert it to however many cars would be per 1 minute. So let's read the mean. It says on average, let's say with the mean time between arrivals of 3 minutes. So it's describing as the time between arrivals is 3 minutes. It's not even telling us how many. Matter of fact, how many cars will arrive on average in 3 minutes to this gas pump? Another 3 minutes went by. How many cars arrived? 1 car. 1 car. Another 3 minutes. Another car arrived. It says on average 1 car every 3 minutes. We got to convert that to how many cars per 1 minute? That's right. A portion of a car on average would arrive in 1 minute, but there's no way, I mean, in reality, you can't get a portion of a car, but what portion arrives in 1 minute if 1 arrives every 3 minutes? 1/3. This is hard. This is hard, I know. Oh my God, let's go home.
How would you solve for it?
Man, we gotta get out early, because today's the 5th. Darn it. All right? So we gotta go home, because right now, this doesn't even make sense. With this Lambda thing. All right? Hang on. We're not done. All right.
Can you give us a different example?
I'm gonna give it different ways here. Different ways. Are you ready? Go ahead.
I was saying, what if it's 3 minutes or less?
If that says 3 minutes or less, you're talking about the question or the question, because you said or less, because the mean is never described as or less. So you're saying the question says, what's the probability that 2 successive arrivals will be 3 minutes or less? That doesn't have anything to do with lambda, because that has nothing to do with the mean, but this first number would change to a 3. That would change to a 3. Here's what the mean's being described. It says the mean time between arrivals 3 minutes. What if that said 2 minutes?
1 divided by 2.
1 divided by 2. Because only a half a car is showing up each minute. If 1 car shows up in 2 minutes, that means a half a car on average would be in 1 minute. What if this said 6 minutes? But there's 6 minutes between cars arriving on average. How many cars would arrive then in 1 minute? 1/6 of a car. You get it?
No.
Hang on now, I got examples here. We're focusing on lambda because this is the hardest part. Focus on lambda. Let's say the mean's being described as there's an average of 3 minutes between a car's arriving And we gotta convert it to how many that would be per 1 unit in the question. The question's in minutes. This would be 1/3. Now let me show you how. If there's 1 car every 3 minutes, that equals how many cars per 1 minute? This is 3 minutes, and this is 1 minute. They're equal. Lambda's all about converting to 1 unit of the units being asked about in the question. The question's in minutes. The means being described as 1 car per 3 minutes. How many per 1 minute? Cross multiply. 1 times 1 divided by 3. 1/3. That's how many cars per 1 minute. 1/3 of a car in 1 minute, 1/3 of a car in the second minute, 1/3 of a car in the third minute. We have a car arriving in 3 minutes. Well, another minute goes by, 1/3 of a car, another minute would be 1/3 of a car, another minute would be the second car, 1 car arriving every 3 minutes. Get it?
We have to convert it to
Right there. Let me show you. There you go. 1/3, or you can put 0.3333 as long as you're using at least 4 threes and you're rounding correctly. That's fine. But you want to be exact, put 1 divided by 3, and that will give you an exact answer. You're rounding when you put 0.333, but it's acceptable. As long as you're using 4 digits. Let's go again. Ready? On average, there's 10 cars arriving every half hour at this gas pump. What's the probability there'll be 2 minutes between, or less, between the next 2 cars? Let me repeat this mean. Now it says average of 10 cars per half hour. 10 cars, here we go, 10 cars per half hour, but this is in minutes. So this would be 30 minutes equals how many cars per 1 minute? This is minutes, this is minute. 1 times 10 divided by 30. 10 divided by 30 equals, look at that. It was described a completely different way. This was described now just like a Poisson question, which many of these exponentials have the description of the mean as a Poisson, and yet it comes out to the same lambda. This is why I'm saying focus on what lambda is, and then focus on how do I find lambda from what's being told to me. Let's do it again. You ready? Hey, what's the probability there's 2 minutes or less between the next 2 cars arriving at this pump? On average, there are 5 cars arriving every 15 minutes. On average, there's 5 cars arriving at this pump every 15 minutes. What would lambda be? Here we go.
Over 15.
5 cars per 15 minutes is equal to how many cars per 1 minute? 1 unit of the, whatever the interval the question's about, which is in minutes. 1 times 5 is 5, divided by 15, 5 divided by 15 equals, look at that. A third way that the means being described to you still comes out to be the exact same lambda, because the mean can be described so many different ways. You gotta say, how do I convert it to the number of per 1 unit of the interval in the question? That's what lambda is. This is the toughest part.
Now, could you do one that's like not, that doesn't give you 1/3?
Yeah, you ready? We're going to page, again, we're going to page 228. Let me go here. Oh boy, I gotta go here.
On a different one.
Boom, boom, here we go. All right, look at number 66. Is it 66 we want to do? I'll make sure. Yeah, 66, B. Says a toll booth operator has observed that cars arrive randomly at an average rate of 360 per hour. Let me write this down. 360 per hour. Now we don't have to change this hour to anything. This is 1 hour. If the question's about hours, but I don't think the question's going to be about hours though. Let's take a look. We're going to B. It says, what's the probability that the next car will arrive within 10 seconds? Is that what it is? 10 seconds. What's the probability the next car arrives in 10 seconds? First of all, is this 10 seconds or less or 10 seconds or more? Within 10 seconds. What does that mean? Within 10 seconds. 10 seconds or less. Top one. 10 seconds or less. So here we go. Oh, that's a 1 on the end. This is a 10. We don't switch that. This is in 10 seconds. We got to somehow convert 360 per hour to how many per 1 second? 1 second. Because it's all about how many per 1 unit of whatever the question is about. The question's about 10 seconds, so lambda has to be how many per 1 second. Let's think about this now. You ready? I gotta convert 360 per hour. 360 per hour, let's at least take that to per minute. How many minutes in an hour?
60.
60 minutes. So there we go. If I take 360 divided by 60, I get 6 per minute. Does that sound right? 6 per minute, but we gotta have how many per 1 second? How many seconds are in a minute? 60. So 6 divided by 60 equals, so here we go, 6 per 60, now we have it in seconds. Seconds is equal to how many per 1 second? Here we go, 6 times 1 is 6, divided by 60. 6 divided by 60 equals 1 over 10, or 0.10 if you want to put it as a decimal, 0.10. That's x. Did you see how we found lambda though? This is the hardest part of today's lecture and Thursday's lecture. All right, I want to give you another example. We're going to keep rolling here. We're going to keep on rolling. I want you to see another example. We're going now to, hang on, 60.
This way.
This is all about finding lambda. So we're going to 67. We're going to C, 67. Ready? Customers make purchases at a convenience store on average every 6 minutes. So here we go. I gotta find a place to put this. Every 6 minutes. Is that right? They're saying a customer, so without using the word between, they're saying in between one customer to the other, how many? 6 what? 6 minutes between purchases. So it's 1 per 6 minutes. There it is. There's how the mean's being described. Differently, this is a little different than this, like the top one up here. Like the top one of these three. This is how it's being described. So purchases, actually, we're going to C. What's the probability that a customer will show up in less than 5 minutes? Less than 5 minutes. All right, are we doing the top one or the bottom one? Is it less? Is it?
No,
Hang on, less than 5 minutes would be 5 minutes or less, so that'd be the top one. 5 minutes. So I'm putting a 5 here. I'm putting a 5 here. Putting a 1 on the end. All that's left is the lambda. Now here's the deal. The question's about 5 minutes. So we have to find how many customers buy things, how many customers arrive up there to make a purchase every minute. Because that's per 5 minutes. So it's how many, what do we have here? 1 per 6 minutes equals how many per 1 minute? There it is. Because it's lambda's how many per 1 unit of whatever's being asked about, which is in minutes. So 1 times 1 is 1 divided by 6. There's lambda, 1/6. It's when the average happens to be described as an interval, it's kind of easy to convert it. You almost just put 1 over it. But don't rely on that. Do the math and do the logic and make sure you're getting the right lambda. Go ahead.
For Poisson, how would they ask that question? Would it be like, what is the probability that?
C would be, what's the probability there'll be 5 customer purchases over the next 15 minutes? It would be how many customer purchases there are. Then you would have to, well, then we'll go back to Poisson, but that's how you recognize it. It'd be asking about how many customer purchases there'd be.
The amount of customers.
I'm sorry?
They would give you like how many customers.
How many customers instead of how much time between the customers. Yeah, this one's about how much time between the customers, even though it doesn't say between, it says, what's the probability of 5 minutes or less before the next customer? But that's in between customers. All right, let's go to another one. I want to keep going here. We're going to go to 68A. You ready? A hospital administrator worries about the possible loss of electric power as a result of a power blackout. The hospital, of course, has a standby generator, and it's subject to failure, has a mean time between failures. Here we go. Let me write this down. A mean time between failures of 500 hours. Is that what that says?
Yeah.
1 failure per 500 hours. There's how it's being described. Now this one's easy because it's being described as time between failures. So it's kind of easy to find. Let's see what the question is though. What are we doing, A, B, or C? We're doing A. What's the probability that the standby generator fails during the next 24-hour blackout? So the question is about it failing in a 24-hour blackout. Hang on a minute. So it has to fail in 24 hours or less, right? Can't be 24 hours or more, 24 hours or less. So 24 hours would be the top one again. We haven't even got a bottom one yet. This is getting crazy. There's 24, all right? And it's in hours, and it's being described as 500 hours between failures. So we gotta say if there's one failure every 500 hours, how many would that be per 1 hour? Because it has to be 1 unit of whatever's being asked in the question, which is an hour. So 1 times 1 is 1, divided by 500? 1/500 of an hour every hour. So this would be 1/500, and a 1 on the end. Almost too easy, we gotta get to a harder one. Go ahead.
Let's say they were asking for them at one, like a minute.
Okay, minutes. Now this would have to be converted. We'd have to say 1 per 500 hours is, and take 500 times 60 to get 1 per how many minutes. Then we would do it again. It'd be 1 3,000 some minutes, whatever it is.
Do the other test, convert it.
Define lambda, you gotta show how you're converting if you gotta convert it, yes. Yeah, because the mean being described is not gonna be described as 1 unit, so you're probably gonna have to show how you found lambda. Let me repeat that. On your homework, on the written part of your homework, which I'm going in detail more on Thursday, and on the quiz, the next quiz, when you're solving for lambda, you gotta show the work how you found lambda. If you're doing a cross multiply, then show it, or whatever you're doing. If you just said, I know it's 1 over that because it's being described as time, write that out for me, or whatever you're doing. Whatever you get in your head to figure out what lambda is, show something that tells me what you did. Okay, let's get to the next one. I want to get these a little harder before we run out of
What
time.
page is this?
So, 70. Here we go, up here. Ready? On average, the state police catch 8 speeders per hour. So I'm switching this now to 8 per hour. So if the question, 8 per hour. Is that right? So if the question's in hours, we already got lambda, right? If the question's about hours, we got lambda, 8 per hour. Let's see if it is, that'd be great. Are we doing A or B? We're doing A.
This is poison.
70A. What's the probability that the state police wait less than 10 minutes for the next speeder? It's in minutes. Wait less than 10 minutes for the next speeder. Are we doing the top one or the bottom one? The top one, because it's 10 minutes or less, is that correct? So what's the first number here? 10. What's the last number?
1.
There we go. Lambda. Here's the deal. It says, what's the probability to be less than 10 minutes? 10 minutes or less than 10 minutes for the next speeder. But the average is being described to us in hours, per hour. It says 8 per hour. We have to convert 8 per hour to how many per 1 minute? How many per 1 minute? Because the question's in minutes.
Why does it say it follows Poisson distribution?
Well, yeah, but that just means that the mean is going to be described as how many. Where's the mean? That's going to be described as how many per hour. 8 speeders per hour is the description, is a Poisson description of the mean is all. But sometimes you'll get it described as how many minutes between speeders could be the mean described. But it just has to be described in a Poisson way. Don't let that persuade you that you're reading a Poisson question, because you got to go to the part where it asks about the probability to determine what kind of question you have. The mean will fool you. The mean will look like you're looking at a Poisson, but really it's exponential, or vice versa. So don't let the mean fool you. Again, what's the probability there'll be less than 10 minutes? So we got to find lambda. Lambda is 8 per hour. We got to convert 8 per hour to how many per 1 minute? We know that an hour has how many? 60 minutes. So now cross multiply. 1 times 8 divided by 60. This is 8 divided by 60, which is equal to, I don't know. No, it's not 1 point nothing. 0.13333 maybe.
1.3.
No, not 1 point anything. No, it can't be. No. 8 divided by 60, someone.
Oh, yeah, 0.133.
There we go, there we go. 0.1333 all the way?
Yes.
Okay. Or you can just put You can put 0.13333, you can, as long as you're using at least 4 digits to round it correctly, or look what I'm gonna do. I'm gonna do it like I'm typing it, 8 divided by 60. I put the exact number in there. There's lambda. How many per 1 minute when you're being told the average is 8 per 60 minutes. Lambda, lambda, lambda. You're gonna hate this word.
I don't like it.
You already. I know, it does that to everybody. It happens fast. All right, we got 2 Excel things to learn, real quick. Let's start with this one. Factorial. Now you don't have to do factorial on your calculator. You can do it using Excel if you want. FACT. FACT, parentheses. Whoop, sorry, I thought I had it on the board. Hang on. Let me switch this. Come on. Where is it? Behind there. Is that it? This it? This it? All right. FACT, parentheses 5, parentheses equals FACT. That will be 5 times 4 times 3 times 2 times 1. That would do factorial for you. All right. Here's a nice one. Equals FACT, parentheses 0, parentheses. I know a lot of people accidentally think that's 0, but it's 1. It's a really weird one. Give me another one. Now we can get into big numbers. Equals FACT 12. 12 times 11 times 10 times 9 times 8 times 7 times 6. Gotta be a big number. There you go. Big number. Whatever that number is.
What, so the number you put up there is the number you're trying to find?
The factorial of a number. Like if we're trying to find factorial of 12. You remember, you remember factorial like this? 12 with the exclamation point. Yeah, some of the formulas have it. Now you can just use FACT.
For 0, we would just put 0 in the parentheses?
Yeah, if you're trying to find the factorial of 0, but it ends up equaling 1, not 0, just so. That's why I put that on there. I want everybody to see that. It's a weird one.
Yeah.
All right, here's
If you
the
multiply
next,
all by
here's
this,
the
it's
last
not-
one for today. Rank,
Makes sense.
R-A-N-K,
Yeah.
equals rank, parenthesis, whatever number you're trying to find the rank of, meaning is it the first number, is it the second number? You got to imagine that here I have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8 numbers in the data. You got to imagine there's 1,000 numbers there. This is why you want to find where a number ranks sometimes, is without putting them in order. You want to leave the data in the order it's in, for example. So we're trying to find out where 21 will rank among all the data. If you notice it has a 0 on the end, comma 0, that's telling it that you want it to be ranked in, is that ascending or descending? I gotta remember, descending order. Descending,
What
right?
about
Going
one?
from largest to smallest, is that right? Descending, ascending?
Yeah.
So let's count it off. 21 would be the 6th number. If we're going from the largest to smallest, so the largest number is 55, 44,
34,
34, thank you,
33,
33,
20, and then
and there's another
34,
34, then 21. So it is going from largest to smallest, descending. If you want to rank it in descending order, you put a 0 on the end, or you don't put a number on the end at all. Equals, rank. Now look at this also. I'm still doing 21, but instead of putting the number 21 there, I'm giving the cell location where the number 21's at. Meaning I want to rank number 21, it's at B9, comma, B8 dot dot, B15, no number after the where the data's at means you want it descending order. No number. If you put a 1 on the end, if I were to go back and put a 1 there instead of a 0, it would then be ascending order. From smallest to largest instead of largest to smallest.
So it's 0.
So look down here, equals, parentheses, 21, comma, B8 dot dot, B15, comma, 1. A 1 on the end means ascending order from smallest to largest, so 21 now is no longer the 6th number, it's the 3rd number. So see, the smallest number is the 12, the second smallest number is 20, the 3rd smallest number is 21, so that by putting a 1 on the end. Now I don't have to use, again, 21, where's 21 at? B9, so here it is, using B9 with a 1 on the end. I could just say, hey, rank B9, which is the number 21. I don't have to tell it 21, I can just tell where the location of the number is I want ranked. Everybody know how to use rank. Everybody know how to use fact.
Yeah.
We're good with those? All right, 2 more in our arsenal of numbers. That's it, that's all I got. We pick up from there on Thursday. I'll see you then. We have an in-class assignment on Thursday. Anybody who didn't sign in, please sign in.